Bidding languages, this section concerns the issue of the representation of bids in combinatorial auctions. Namely, we are looking for representations of valuations that will allow bidders to simply encode their valuation and send it to the auctioneer. The auctioneer must then take the valuations bids received from all bidders and determine the allocation. Following sections will consider indirect iterative ways of transferring information to the auctioneer. Specifying a valuation in a combinatorial auction of m items requires providing a value for each of the possible 2 to the n-1 non-empty subsets. A naive representation would thus require 2 to the n-1 real numbers to represent each possible valuation. It is clear that this would be completely impractical for more than about 2 or 3 dozen items. The computational complexity can be effectively handled for much larger auctions, and thus the representation problem seems to be the bottleneck in practice. We will thus be looking for languages that allow succinct representations of valuations. We will call these bidding languages reflecting their intended usage rather than the more precise valuations languages. From the outset, it is clear that due to information theoretical reasons, it will never be possible to encode all possible valuations succinctly. Our interest would thus be in succinctly representing interesting or important ones. When attempting to choose or design a bidding language, we are faced with the same types of trade-offs common to all languages. Design tasks. Expressiveness versus simplicity. On one hand, we would like our language to express succinctly as many naturally occurring valuations as possible. On the other hand, we would like it to be as simple as possible, both for humans to express and for programs to work with. A well-chosen bidding language should aim to strike a good balance between these two goals. The bottom line of this section will be the identification of a simple language that is rather powerful and yet as easily handled by allocation algorithms as are the single-minded bids studied in section 11.2.